All right, number 43 here is a lot like 41, which I just did. Directions say find the one-sided limits and either do it numerically or graphically. So I've been set up to do numerically for a while. Although, if I think of it, I'll show you at the end here. Once you get it set up to do numerically, graphically isn't really a whole lot harder. The tricky thing you're going to have to do in all these problems, though, is redefine your function each time that you do it. So here we go, guys. We are going to redefine, so action 1-1 again. And I keep calling this function f1 of x. Gotcha. It equals, in this case, another stacked fraction. And in 43, it is going to be x minus, this is kind of interesting now, the sine of the absolute value of x. So sine, and again, I would just type in the letters here, a, b, s, and then go back to where we were, another set of parentheses, and then an x there. So x minus the sine of the absolute value of x all over x to the third power. So if we hit enter, okay, that does about what we want it to do. And I think I got lucky here, guys. In 43, it is again, the limit as x is approaching 0, just like it was in number 41. And what's really convenient about that for me is that my table is already set up with what I need it to be. As x is approaching 0 from the left, that's what these numbers here are indicating. And then as x approaches 0 from the right, that's what these numbers here are indicating. And boy, this is interesting. Something weird happens. Let's take a look at what we have going on. And if I take a look at these values, if you look up at the top of my screen here, guys, I can see that this number looks like it's what? 222,000. Then it jumps up to, wow, 500,000. Then it jumps up to, that looks like about 2 million. What I think I see here is that my y values here are increasing without bound. So without taking the time, because this would be really boring, to fill in this entire table here, guys, we were at negative 0.003, negative 0.002, negative 0.001. What seems to be happening right here is that my y values are increasing without bound. And that means that my left-hand limit right there of this function, as x is approaching 0 from the left, seems to be infinite. Once more, those y values that are right here, and you kind of have to zoom in on them to really see what they are getting bigger and bigger and bigger. However, a weird thing happens down here on the bottom. If you take a look at these three y values right here, at least at first glance, they all appear to be the same, you guys. And if I click on just one, if you take a look at that decimal number up above, I can tell that they're very, very slightly different, but not really that much. They all seem to be converging towards that same number right there, which is 0.167. So that's kind of what I see here if we're going from 001, 002, and 003, these values all seem to be narrowing in on 0.167, which, if you have good mathematical instincts, guys, you might recognize is the fraction 1/6. So that's odd. As x is a positive number right there, we seem to be getting that same value each time. So it looks like we've got two different answers right here for problem 43. Our left-hand limit is infinity, increasing without bound, but our right-hand limit is going to be 1/6.